while I could continue with the shooting of Dan McGrew, I think I should actually probably officially continue with the talk that I'm supposed to be giving. Though if you like shooting of Dan McGrew, we can go through that later. I'd be very happy to. It's an all-time favorite of mine. Louder? Okay, I will start swallowing the microphone. So, this morning I'd like to talk to you about some problems that I've got, which are, we won't talk about those, we'll talk about a different set, which are fundamentally that I do mostly corporate network information security defense. This is a hard job to have since, as Bruce pointed out, it basically means you're losing and you're accepting losing, and at best you're not failing quite as often. And your users never really appreciate the fact, because if you're doing your job, they'll never notice. In addition to that, we actually had to start figuring out what we were going to do about some fairly ugly problems that we ran into about 4 years ago, and were getting worse and worse, to the point where we really realized, you know, this takes a radical change. So today I'm going to run you through the problem that we were running into, the approach we took to trying to solve it, the method that we used, the solution, and our progress to date. We've been working on this for about three and a half years. We're nowhere near done. It's going to be a continuing progress, and at this point we actually see that we've gotten some pretty significant progress, and we think it's fairly interesting. The problem that we've run into, and that we were running into, and I'm sure all of you are aware, is that the security model that we've had going back the last 10, 20 years really just doesn't meet it anymore. It doesn't give us the set of solutions that you need. And if you're dealing with a large enterprise, and I have a fairly large enterprise that I'm working with, you end up with a huge demand from the customers for a set of capabilities that you really have no clean way of securing. And so on one side, you're having people come to you and say, I want to be able to access my enterprise resources from this stupid little device that's got no meaningful operating system, no meaningful security, and oh, by the way, I want it now. And you look at that and say, well, okay, so maybe I can give you some level of really, really narrow, horrible access that you'll hate and it'll be impossible to work with. It's also going to cost you $500,000 because I'm going to have to build out all of the custom infrastructure for it, or it's going to take me a year and a half because I'm going to have to build it all custom and do very silly, simple things, and it's not going to be a good solution anyways. It's not. Swallow the mic even further. Okay, I will keep swallowing the mic. By the way, I love feedback. I love comments. I love questions. If it's a good one, I'll even love it in Homino Attack. I don't really appreciate anonymous cowards, so if you want to say something, please shout it out at any point. If you use the moose, I'm going to ignore it, and I believe they turned the sound off, so I really can. But
Moose is dead.
The moose is dead? So the moose is dead. That doesn't mean you shouldn't be asking questions. I love questions. Please feel free. So we have the problem of the changing security model. We've got the old style security model that we built out. It was very static, was very limited. I think you're all familiar with this part of it. The thing that we started getting pushed by were the uses for social computing, the requirements for additional small form factors, and small form factors. I have a company full of technology zealots and enthusiasts, which means they constantly want whatever the new hotness is. Doesn't matter whether it's usable, doesn't matter whether it's a good idea, they always want it. So we're always getting asked to support something new and random that you can't get the necessary controls for. You can't get VPN clients, you can't get IPsec, you can't get antivirus, you can't get intrusion detection. Most of the little devices don't even have decent logging, so you can't even tell if they're compromised. And oh, by the way, these days they all have WebKit. So, on top of this, we've got the change in the attack landscape, which I personally take great pleasure in watching, and I think as a constant source of entertainment makes my life actually pretty entertaining. From a professional side and a defensive perspective, it certainly makes things more difficult. The quality of attacks, the level of skill necessary to exert a high-quality attack has dropped. The quality of attacks in general has gone up, and the volume has certainly increased. So a couple teammates of mine and I started thinking about this, and independently actually approached our management and said, we think we can try and do something about this. And they said, great, what do you want to do? And this is what we came up with. We're not sure how we would do this, but we think that if we started with the idea of where we would go from scratch, just completely greenfield it. What would we get if we could completely greenfield and build out a completely new IT infrastructure? Completely replace everything that we have in the environment. We took a small focused team. We specifically pulled people with a wide variety of skills. We got networking, we got systems, we got programming, we got defense, we got attackers is the ones that we had. We specifically pulled out deep technical knowledge people who liked thinking big, silly thoughts. So you get people who could yo-yo very well from the very deep technical levels, and the people who were still spending their time fixing the environment and implementing solutions all the way up to, I can give you something that's going to be a wide-ranging solution. The entire team had to agree on all the members, and anytime we add a new member, we had full veto rights over anyone being added. The reason we did this specifically is we wanted people who could handle being told, no, I can't believe you ever thought of that, you should be ashamed of yourself. With total aplomb, with no problem, smile and keep going. The result of this is that we've got a core team of 7 people who, after 3.5 years, still really like each other, still get along well, are still in sync, and able to communicate the idea that we came up with effectively. This has been absolutely critical. This is one portion of the material we're presenting, but I'm telling you, if you're doing something on this scale, changing the entire IT security infrastructure for a corporation of 100,000 people, many hundreds of thousands of nodes, and a huge diversity of types of environments, you need something like this. It's one of the critical pieces. We made it clear that management had no say in anyone who was going to be involved in it, and we made clear that we didn't know what we were going to come up with. So what do? They locked us in the basement, and by the way, I'm not exaggerating, this is the subfloor beneath a data center. There was no light of day. We didn't know what time it was. We locked ourselves in for a week, sat there, and started complaining. Started debating, started arguing, started laughing at each other, checked all the attitude at the door, tried to figure out what we could build and what we needed to do. At that point, we actually ended up coming up with something fairly interesting. We built it out for a while, and what we eventually came to was a set of basic principles that we could build into a complete architecture, but also that we could integrate into the way engineering was done in addition to adding new capabilities. By changing parts of how IT engineering was done and adding new expectations to them, we could actually effectively ensure that the environment that we were building and improving would be able to sustainably scale and to adjust over time to the continuous changes, so that the next time we create a new mode of computing, let's say all of a sudden everyone has car computers now and they all want to run DOS or Windows 3.1, we can actually adopt capabilities and support some access to them. The next time we start embedding computers in people's skulls and need to be able to support direct interface where there is no keyboard and the only thing you get for passwords is colors, you can support these capabilities. We set up a couple key characteristics. We started calling them layers, we called them pillars, we called them columns. They're just a set of ideas. One, a dynamic trust calculation. The ability to say, yes, your permissions may be set X, but at other times they may be set X plus 2 or X minus 5. They adjust over time. Isolated security zones. This is a very old principle. Everyone should be familiar with this. This is the idea of actually enforcing not just at the network boundaries, but even within internal environments, strict isolation, logical and physical, of the environment. Aggressively balancing controls, and I'll get through all of these, I'll go in more detail, but actually enforcing and requiring sets of balance controls, not just prevention, but actual detection and correction. We started adding additional perimeters. These are a little more fuzzy. These were created, well, there was one highly influential person who really wanted to see them in there, but we specifically called out, look, you have to take into account social engineering is massively on the rise. We need to be doing something about the fact that users really are going to be a critical failing. And as we've seen, every time a new technology comes out, the same things work. Spam? Yeah. Old school con artist, or old school confidence game. Worked when it turned into spam. Then it worked when it started going over instant messenger. Then it worked when it went into Second Life. Then it worked when it went into Facebook and into MySpace. It keeps working again and again. You have to accept that it's going to. The other piece is that data is going to start needing to be able to have some level of protection itself. What that means, it depends on who you're talking to and what you can implement. Personally, I don't believe you can build a house on sand, but you can at least create a box that is unbreakable without a tremendous amount of effort, and then put it on somebody's sandy beach and they can play with it as much as they want as long as they don't care to get into it. If you can follow that analogy, you're doing better than I am. So, we started doing ongoing coordination, and we started giving guidance, because the problem is we had a core team that was chosen because they were well respected and they got stuff done. But when you're well respected and you get stuff done, you're really busy. So we had full-time jobs already. This was taken something to do in addition and on top of it. We spun off a separate set of sub-teams that were going to be responsible for implementation of different aspects, and we've actually had tremendous success with this approach. The core team continues to go out and stick our noses in other people's business and say, hey, wait a minute, we're going to change everything about how you're engineering, or at least these subtle things you're going to do completely differently from how you've done in the past. No, we're not going to do the work for you. We're just going to come in and advise you. This allows us to land in a team, influence them, modify some of what they're doing, get them in line and rowing in synchronization with us, in synchrony with us, and then move on. It makes it a lot more efficient. And we've spun off teams where we needed to do dedicated engineering specifically for that purpose. Any questions so far?
When did you take into account budget?
When did we take into account budget? At this point, we hadn't. And the answer is, to some extent, on an ongoing basis, we take into account budget, but part of our success has been a refusal to be limited by the standard sets of, oh, that'll never get paid for. Frequently what we've actually done is gone in and said, this will cost this much. On the other hand, if you don't let us do this, you won't be able to have this capability that you want, and this capability that you want, and this capability that you want. And if you did want them without us going in delivering this engineering solution, it would cost you 5 times as much. We help them see that it is more efficient cost-wise to do what we are suggesting than to refuse and then try to get the features they want in other ways. And I'll get into a little bit of that later in terms of some of the things we've done well, but by refusing to consider that there might not be budget available, we've had significant success. We've just simply bowled past that. It also helped that we chose a team of people that, like I said, were well respected. And so when we went to IT staff and executive staff and said, this is how much we need and this is what it's going to take to do, they said, all right, let's start doing this. So, the first place to start, the dynamic trust calculation. You're all familiar with the idea of access control. You get rights based on who you are, based on something you know, based on what you have need to access, RBAC, the whole 9 yards. This is not necessarily a complete replacement. Well, it's not in any way a complete replacement of that. What this is the idea that the level of access you should have should be dynamically adjusted based on a series of characteristics that we built out as a team. The fundamental set is, at a high level, your source trust calculation plus your destination calculation results in a level of access. The calculation is done as often as necessary. Now, at the beginning and where we are today, we're doing this in a very limited fashion, but over time we expect to see it recalculated much more frequently and much more dynamically. We're expecting any time, right now we're focusing on session establishments because that's a very easy place to kick off this sort of thing. Just one second, Joe. We're also expecting, though, over time to start tying in detective control feedback loops. So if you start seeing anomalous behavior in your detective controls, in your monitoring environment, you can force a recalculation of the trust calculation and change the level of access that somebody has. Change in any of the trust calculation characteristics, which I will get into now. Joe, what was your question?
I'll actually just answer.
Okay. So, the trust calculation breaks down as follows. We'll go through each piece of it. The source trust comes from who you are, what device you're using, and where you're actually located. This is all mitigated by our level of confidence in that data. So for instance, if you give me an IP address for your location, I'm going to smile very politely and say, isn't that cute? I'm not actually going to use that to validate any level of significant access unless I have control over the back-end infrastructure for some reason, which lets me determine, oh yes, I actually did assign you that IP address, and I know for a fact that you're sitting on that network because there's no way you could be coming from another location. If, on the other hand, I have the logs from my wireless access point and I know that your device is sitting on there, that's a pretty good indication that your wireless device, that your mobile device, whatever, your phone, your laptop, actually is on that network. Now, it doesn't necessarily mean that you're not getting a man-in-the-middle attack or a proxied attack through the system, but it does give us some physical location for that device. Who the user is. This is obviously a basic piece of any calculation. I'm not going to spend a lot of time in it, but what I will mention here is that because this is a dynamically determined calculation, one of the things that we are able to adjust is we're able to adjust for the different kinds of authentication that are available in different environments, which means that, for instance, if you have a device that can provide a strongly protected certificate or an OTP, or any other strong level of authentication, we can give you greater levels of access because our confidence in that data set or in that data goes up, which is where the calculation comes down to the bottom piece, which is our confidence in each piece of in each part of that calculation. The lower our confidence, the lower the level of access you get. So if you say, I refuse to use strong authentication because, you know, I have an iPhone, and if Steve Jobs wanted us to use special characters, he would have given them to us. If you refuse simply because of that, well, that's okay. That just means we're going to lower your level of access. On the other hand, if you decide that you're willing to use full genetic sampling and give a drop of blood and do DNA tests every time you log in, we'll give you a lot more access based on that. It'll be a little slower, but we'll still do it. Finally, the where you are physical location. This is one that we debated quite a bit whether we wanted to include or not, and the general consensus was it's not necessarily going to be a common piece of the puzzle, but that it offers some very interesting capabilities. It also runs into offering some essential things depending on the environment that you support. So this may actually be a community that's familiar with the term controlled technology. Show of hands, controlled technology? Very few people. Think things like ITAR. Anything that would land under ITAR restrictions, stuff that can't go to certain countries in the world. Well, if you happen to be a company that makes ITAR-related hardware, and any of your products end up in one of those countries, you don't just necessarily get fined, you potentially get put out of business. So it's a bad thing to have happen. One of the pieces that comes in here is when you can say, based on your location, we're going to give you access or not give you access to this data, then we can actually enforce the level of restriction and control necessary. Next piece is the destination calculation. The destination calculation includes who you are again, but in this case, the who you are is different. This comes down to what application you're actually using to perform the request. And this is a useful distinction. It ends up playing more into the sorts of controls you're going to have available on that device, on that platform. So for instance, if you're willing to use Microsoft Office 2010 with Microsoft's enterprise rights management system in place, then we may be able to give you a copy of a document with a lot more data in it and a lot more access to useful information than if all you want to do is have VI running on a Ubuntu 8.x Linux system. We can actually control and enforce some level of restriction upon the data and how it's handled. And so it ends up being a separate piece of the calculation that has to come in. What do you actually want access to? And this is both data classification, but it's also potentially impact of the access to the environment. So it's not just is the data sensitive, it's do you want to perform, for instance, WAN configuration engineering. We have one team member who is our senior WAN engineer, and our general plan is to restrict his ability to do his job until he has to stand in a telecom closet in the middle of highly northern California where there's nothing around anywhere, far away from his home in a little cramped space. This is he seems to be good with this. He likes being in small enclosed spaces. And finally, where is the data located? This is one that we've left in. We haven't used it a tremendous amount, but there's some interesting implementations of control systems where in order to get access to data, you have to go to where that data is located. So for instance, source code control, where you have to be in a physical location with that source code in order to perform the actions. This is common when you're dealing with things like, for instance, certificate authorities, and you're generating signing certs, say, for device drivers that will be on 20, 50 million laptops around the world. Starts coming into play a little bit there. You perform these two pieces of the calculation and you get some level of access out of it. Now, the standard answers are access denied, access allowed. Those are really simple, those are really obvious, but a coworker of mine who I like to argue with a lot, mostly because he's always wrong. He's not. Either I am or he is. One of us is. Clearly, it's no gray matter or gray area between it, and there's not a lot of gray matter either. Brought up some interesting cases. What do you do when you need to have a senior fab engineer, manufacturing engineer? And for us, when a manufacturing space goes down, that's supposedly $1 million, $2 million an hour. Lots and lots of money going down. And you have a fab engineer who suddenly needs to do something right now to do administration in the environment. They happen to be sitting in a cyber cafe in Russia. How do you give them the necessary access? Well, the default answer is you don't. Absolutely, why would you ever do this? And the answer is, sometimes you don't have a choice, you have to find a way to give them access. So that's where this ends up coming into play. And that's really where this becomes tremendously useful, is that sometimes you can't just say no and yes is the wrong answer. You have to figure something out. This is where you get the mediated access that we're talking about, and is the restricted sort of adjusted access in the middle here. This is the idea that maybe the access becomes logged to the point where you can aggressively roll back every single step in the process. This may be, if it's access to a set of files, a throttled level of access to files. Maybe somebody is acting anomalously, but you don't want to keep them from getting a set of files. You just want to slow down the pace of collection of files. Maybe you want to check with their manager and then allow the manager to come back and say, yeah, this really is necessary. I'm going to approve this even on the fly, and adjust what the people can get access to. Maybe this means you rack DRM around the documents that you're delivering access to. Maybe you start implementing a workflow that has multiple steps of authentication and authorization for anything that you're starting to add. This is where you really get into adding some flexibility around the access that you're granting. Maybe instead of being able to perform all the actions they want, they can only read data. That's the basics of the dynamic trust calculation. I'll walk through in a couple minutes an example of what this looks like. I think that'll probably help a little bit. The next piece is the isolated zones. This is really old school networking. This is not surprising, I think, to anyone, the concept that really your network should be separated. What we're trying to do, though, is assert that within your environment, you segment it heavily, and that you don't only segment it based on layer 3, layer 4, but you actually push all the way up to layer 7, ideally layer 8 if you can get away with it. And you block and control and restrict so that, for instance, if you need to serve DNS and DHCP from your trusted environment, because they're going to be clearly trusted resources, and so they're going to land in your highest trust environment, they've got to be able to serve that data all the way down to your completely untrusted environment. You wrap application proxies around them. You restrict access to what's being requested. You specifically dedicate bastion hosts to provide filtering of what can move through the environment. The idea being that even though you have some pinholes moving through from the bottom to the top, that level of access is mediated and controlled. The other key point to take away from this is, move the right way, that as you move up the stack, the types of applications and locations that are going to be allowed to be used are going to decrease. So at the bottom of this, and this was one that really was important and really sold our IT management on the idea of how this would implement, is that at the basic level, this could potentially allow any device to be used. And I don't know how many of you are in environments that are in the midst of the bring your own blank fervor. Some of you? Okay, I know certainly it's one thing that we've been running into. BYO, 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 whatever. The idea here is that this creates a general available computing environment that allows people to compute and work from just about any silly device they want. Look, if you want to take an iPad or another tablet and claim that you can use it as a decent keyboard, you go right ahead, because we will give you some level of access to do so. You won't get access to everything, but you'll be able to do most of your job from that device. At the same time, on the other side, the level of controls will continue to increase, and their reach across the environment increases to increase the level of security as you move up the stack. Any questions at this point? Yeah. Isn't the level of control depending on who is accessing the data? Yes. In this case, you can think of it less as additional controls, more as modifying the capabilities and the configuration of the controls. Other questions? Yeah.
Are you only applying this from a technology standpoint just with network devices, assuming smart networks versus smart devices? Or are you also applying with this model devices themselves have intelligence enough to define the trust level that...
Right. The question is, are we applying this to devices or just to networks? We're starting with networks and servers and applications, and eventually, as we have some means of doing so, we'll put it in place on clients that have some capability here. But by default, we don't trust the clients. And until somebody convinces me for another, that there's a reason to trust the client. Now, there have been some interesting technologies that have been coming out. We've seen things like security cores in certain CPU designs that look fairly interesting and offer some capabilities. And of course, anyone who's got the Rainbow series remembers the joy of a reference monitor. And once that comes along, we'll see where it goes. Yeah? The question is, are we doing only client to server or user to server, or is it also server to server? And it's absolutely server to server, though honestly, that's something that is still being developed. It's seen as a lower complexity piece of the puzzle, simply because we can do some basic level of filtering and enforcement there and define a much more predictable sort of behavior set between them. But it's much more politically sensitive, because anytime you go to a system administrator or an application owner and say, we're going to put firewall rules in place between your servers, even if you're promising to be really, really careful, they respond with a great deal of hostility. You know, you'd swear it's like you're trying to take oxygen away from their baby. They don't take it well. But yeah, that absolutely is part of the plan. Okay. So, to give you an illustration of how this starts to play out, if you think about your sort of classic model today, and this is one of the ones that I think most environments end up dealing with, you've got your corporate environment in the back end. You've got all your access, all your resources, and you've got your users coming in on various devices. And it's completely location blind. In addition, not only is it location blind, but there's very poor granularity in terms of what they can access. If you have a smart device, you may be using ActiveSync to do some level of restriction, or something, application proxy to do some level of restriction of access. But by and large, when you start getting into things like VPN access, very few environments actually restrict access based on the device and based on the needs of the device. Pretty much for a lot of environments, once you're in, you're in. What we want to move to, and what we are moving to instead, is a model that starts building out like this. The ability to identify a series of different locations and different devices that are going to be used differently and independently at different times, access to a different set of resources in either trusted, untrusted, selective trust. And our expectation, by the way, is that most things will probably be in the selective trust level. The other thing that it's worth noting on here, and I didn't put it in, we've argued about it quite a bit, the zones, the trusted level, the selective trust, and the untrusted, they're not monolithic. They're not uniform at this point. You can think of them as a large number of small zones in that space. A trusted zone is not going to be a single trusted zone that contains your DNS and your domain controllers and any authentication and your NFS systems and everything else. It's going to be trusted zone which contains authentication, Trusted zone, which contains networking systems. Trusted zone, which contains high sensitivity data for this project. Trusted zone, which contains high sensitivity manufacturing systems for this other thing. And the idea, going back to the question about separating out the systems, the servers from each other, that's absolutely where that starts playing in. So these are intended to be striped down to a very fine granular level, but when we start ending that much, it gets ugly. People like pretty slides. Yeah?
How come you classify, airport, differently than you would hotel in terms of level of trust? It seems like it's sort of the same kind of, they're on the move, so you would know that you're going to be there.
Why are we classifying airport differently from hotel? The answer is we're actually not. We're just in this image calling them out as two different locations that may have some level of different characteristic. They won't necessarily, but they can.
Just that, you're singling out hotel for a higher threat, whereas, it looks like you're not doing that for airport on the job.
Hotel. Yeah, it's theoretically. So I suppose if you want to get into the semantics of it, we can argue about whether a hotel is going to be a higher risk. And the fact is that if you want to attack a certain company, you go to the hotels that are nearest one of its sites, you know that you're going to be able to target that. Whereas if you're at an airport, you're going to be getting a much more general view of your attack space. You won't be able to hit that specific target as easily. But honestly, this is just an example. You should not take this as policy or authoritative in any way. Okay? So how this ends up getting implemented, like I said, it gets broken down based on into smaller chunks. And what you start seeing instead is the idea that from different locations, you have different levels of access to different parts of the environment. You actually build out and specifically have different paths that let you get in at different levels. And this doesn't make a lot of sense in and of itself, but the dynamic trust allows you to recalculate this. And what you see then is an ability to push down resources in different formats and different capabilities through that environment. So that what you have is, for instance, a simple capability. Let's talk about salespeople. They have to be able to do some basic capabilities. They need to be able to, wrong arm. This arm is purely decorative. If you think it works, it's just because it's kind of hanging here. A salesperson is going to have to be able to create new customers, create new pricing, place orders, do a number of other sorts of things. They're going to want to do this from different sorts of devices. Now, obviously, we need to let them do their work from wherever they are and whenever they are with whatever device they're on. How do we do this? Well, obviously, the sales data and the back-end sales system is going to be in the trusted zone because it's got to be trusted. By the way, the concept of trust isn't just about the importance of the systems and the importance of the applications. It also makes an assertion about our confidence in those systems. So any system that lands or any application that lands in a high trust zone means that we have a high level of confidence that we are able to monitor it, secure it, and recover anything that happens to it. We assume compromise will occur, but we also assume that we are going to be able to detect the state of compromise, which means that when a new application is moved into an environment, it is hardened to the point where it adds as little new attack surface as possible to that environment. So you'd have the sales application sitting in the trusted zone. The salesperson needs to be able to get access to it. They're wandering through customer sites. They need to be able to do various sorts of things, but we need to be able to restrict it. Let's say they're sitting on their smartphone and we provide some level of access. We're only going to allow them to do the basic sorts of updates, read some customer information, look at commit dates, look at past order information, the sorts of things that they're expecting to be able to do walking into a site, double checking sorts of things. This is going to be controlled even though the application on the back end says, oh, user X, yeah, they have access to do anything they want. At some point, the application will be able to implement the dynamic trust that we want, but until then, you use application layer proxies by and large to actually implement this sort of capability. You proxy in the level of control that you need and say, instead of having full access, we're actually only going to allow you to read these specific pieces of information. And oh, by the way, we're going to be logging and tracking everything you look at. And if you look at too many new customers or too many pieces of data, we're actually going to throttle back your access or potentially remove it completely in addition. They move to a different location, they start using a better system. Let's say on the left-hand side you have a device that we know nothing about. It's their car computer, it's a kiosk in the hotel, it's something like that. They have very limited access. They have only display-based capabilities so that no data is left resident on the system, and they're using authentication systems that are more robust when it comes to keystroke logging, resistance, and other sorts of issues. In the middle, we move them over to a set of platforms that we actually have much more control over. Maybe this is going to be their corporate laptop. Maybe this is going to be a corporate handheld device that has management capabilities built in. Maybe it's an operating system that we trust more. On this system now, they actually have the ability to do much more interesting things. They can create new orders. They can review pricing information. They can actually start getting much more interactive. This means that when they are now done for the day, they can go back to a location that maybe we're not very confident about, but they're doing it from a trusted device or a more well-documented, more controlled device, and so we're going to allow them to do more things. We still know they're in an untrusted location, and so we're not going to allow them to do most sensitive things. But in general, they're going to be able to do most of what they need. We'll still be watching them closely. We'll still be looking for signs and proof that human interaction is necessary. Then they finally move back onto an actual corporate site. And at this point, they're in a network that we know we have extensive controls around. We have the ability to monitor closely. We know what the likelihood of man in the middle is, and we know our ability to detect man in the middle or other sorts of attacks in the environment. We have much more robust sets of controls. So in this environment, we're going to allow them to do all of the things that they are authorized to do as a salesperson in general. And this is the only case where they actually have the full comprehensive set of access that their user account and their privileges personally would allow for. This allows them to do their entire job without creating additional risk. At a basic level, the idea is we want to be able to add new capabilities and do silly things like, read sales information from a kiosk in a hotel or a cafe without increasing our risk. Yeah, question?
So, like, how do you handle the user education aspect of having kind of a changing, user experience depending on?
We speak very slowly. The question was, how do you do user education? Actually, that's a really good question, and it's one of the hard pieces of this that we have been working on and we expect to have to continue working on, especially as we implement this. We recognized from the start that it was going to be a significant challenge for users to understand why their privileges had changed. And one of the things that we're working to build out as we're building this entire thing is the set of explanations of, you don't have access right now based on X, Y, and Z, or you don't have access right now, feel free to contact this support desk in order to get the information that's necessary to understand why you don't have this access. But we expect that to be somewhat of an ongoing struggle. It's always going to be an issue. That said, it's a necessary thing. Question?
Were you able to do this without an application rewrite?
Speak up.
Were you able to do this without an application rewrite?
Very good question. Were we able to do this without application rewrite? Well, to start with, we've actually had to, and I actually touch on that later, but I'll run through it. It's very simply, you've got a sort of cyclical problem, which is you can't have the applications consume the data until you're producing the data, and you won't necessarily be able to produce the data in the way that's necessary until the applications are able to consume them, which is waiting for the data to be produced, which is, so what you do is you cheat. You use, now, I don't think I'm supposed to say cheat. You get creative and you implement solutions that don't require a complete rebuild of the entire environment. We're starting mostly by doing proxying, by using application layer proxies, by using filters, middleware systems that allow us to actually change the level of access, even though the back-end system isn't intelligent enough yet to do that. However, one of the next major pieces of this is going to our entire enterprise application team and saying, this is going to have to change, you're going to have to be able to integrate these capabilities. We expect that to be a long, slow process. Yeah? How do we guarantee location? We don't. Yeah, we don't guarantee location. One of the pieces that comes into play here is our confidence in the data, and location is one of the ones that we have the least confidence in. At some point, someone may come along and give you trusted GPS, but it doesn't exist. You can, however, if you control the infrastructure, identify the devices that are attached to your infrastructure, and use that based on your knowledge of where your infrastructure is to do some level of determination. You can also check things like, for instance, when somebody swipes their badge, that produces a record, and that gives you some level of confidence that at least that person's badge walked past there. if the same time as somebody's badge walks past, a device that they've used for an extended period of time walks past as well and connects to your network, that gives you a little more identification of location. Location, we don't guarantee. Other question? Yeah.
For a company the size of Intel, how many of the day in the life type scenarios do you have to come up with before you reach, enough for it to be a tipping point to be useful across the entire organization? I mean, it seemed like that was a great example, but it seems like you would have like thousands of them.
Oh, okay. So the question is, it's less about the scenario itself. It's more about how do we create the granular flow for each application. The answer is that's done as we get more and more into doing this with the applications, and in the applications, it's going to be done on a per application basis. We're going to require application developers and the application owners to define how their apps gracefully fell back to lower levels of access. But it's going to be a massive task, and it's already something that we've been working on. Right now, the way we're gracefully falling back is actually not